Researchers, physicists, and chemists at the University of Bristol began developing what is now known as radioactive diamond batteries back in 2016. They marketed their creation as a beta-voltaic gadget, which detonates that is powered by nuclear waste beta-decay. Hello my people, before we start with this episode today, make sure you're subscribed to our channel and drop a like. It is safe to say that no modern gadgetry would exist without the simple battery. From hard pacemakers to smartwatches and electric cars, everything that requires electricity to function, but cannot always be connected to a power source, uses some sort of battery. As a result, the battery industry is one of the hottest in recent times as various companies compete to produce the best battery in their class. The nuclear diamond battery, which can last for 28,000 years, is a novel battery material that has recently entered the market and is shocking the entire industry. What is this new battery? How does it function? And why is it receiving so much attention? Join us as we provide you with all the information you require regarding the amazing nuclear diamond battery that is shocking the whole industry. Which would you prefer to use to fuel your electric vehicle? The waste from a nuclear power plant or your smartphone? Many people cringe when nuclear materials are mentioned because of the dangerous radiation they emit. Yet the waste from the process of producing nuclear materials can be the source of nuclear energy in the future. While lithium-ion batteries undoubtedly played a significant role in the spread of electronic devices, they have some drawbacks that are serious enough to drive scientists to continue looking for better batteries. Diamond batteries are a huge step up from the standard lithium-ion batteries that are all around us. Due to their poor energy density, lithium-ion batteries are less than ideal for use in electric vehicles. Some individuals are hesitant to adopt electric cars since lithium-ion batteries must be heavy in order to give respectable driving ranges, but they lag behind gas-powered vehicles in terms of the distances that they can travel on a full tank. When compared to filling up a car's petrol tank, which only takes a few minutes, lithium-ion batteries also take a long time to charge. You could be stuck in one place for almost an hour to fill up the battery, even with the fastest charger. While it's true that prices have decreased dramatically, lithium-ion batteries are still expensive. In fact, because of the battery, electric cars cost significantly more than their gasoline-powered equivalents, and are therefore out of the price range of the majority of automobile buyers. Another issue with lithium-ion batteries is their short lifespan. All lithium-ion batteries suffer from degradation, which causes them to gradually lose capacity over time. This issue is more obvious in devices like smartphones, whose batteries may find it difficult to maintain a good charge after a few years of use. Your smartphone from 3 years ago won't survive as long as it did when it was new, but the automobile is still great and the battery needs to be changed. It's a costly move. To create the ideal battery, scientists have experimented with a range of battery components and materials. For instance, solid-state batteries, which are an evolution of lithium-ion batteries but have some advantages like enhanced safety and better energy density, have received interest. Nuclear diamond batteries are batteries that can endure thousands of years and aid the environment by using up materials that may otherwise pose a safety issue. Graphene batteries, lossless batteries, and many other types of batteries cannot promise the same durability. If the battery in your smartphone lasts 28,000 years, the phone will no longer exist. A group of scientists from the Universities of Bristol and Bristol came together in 2016 to work on a project they named a beta-voltaic device. The name was chosen because it was powered by nuclear waste beta disintegration, but the batteries later earned the moniker radioactive diamond batteries. A process known as beta decay occurs when an atom's nucleus has an excess of particles and releases some of them to achieve a more stable ratio of protons to neutrons. This results in beta radiation, a type of ionizing radiation that contains numerous fast, high-energy electrons, or positrons, known as beta particles. In a conventional beta-voltaic cell, tiny layers of radioactive material are sandwiched between semiconductors. As the nuclear waste decays, it generates beta particles that dislodge electrons from the semiconductor, generating an electric current. Nuclear batteries are much less efficient than other forms of batteries because the power density of the radioactive source decreases the further it is from the semiconductor. However, there's a remedy for this: polycrystalline diamond, or PC. Chemical vapor deposition, a method frequently employed to produce synthetic diamonds, is the method used to produce radioactive batteries. However, by employing radioactive methane, which can be recovered from a radiation reactor and contains the radioactive isotope carbon-14, researchers have altered the procedure for manufacturing radioactive diamonds. Blocks of graphite. These diamonds have both semiconductor and radioactive properties. A battery life without the need for charging, where the radioactive waste inside of it serves as endless fuel, allowing it to charge itself for a very long time with little or no detectable degradation over a very long time. A single battery may theoretically be used for over 1,000 years without needing to be replaced or even recharged. Nano Diamond Battery, or NDB, is one of the startups engaged in nuclear diamond batteries. The company bases its batteries on powerful diamond-based alpha, beta, and neutron voltaic formulas for long life and green energy batteries with the goal of powering devices ranging from tiny insulin pumps to space rovers traversing the surface of Mars for decades without human intervention. For the right context, NDB has been employing layers of impossibly thin-paneled nanodiamonds to construct its nuclear diamond batteries. As the best-known naturally occurring heat conductor and being 3 to 4 times more effective than copper or silver, diamonds are preferred by this industry due to their outstanding heat conductivity, which makes them suitable for electronic devices. Chemical vapor deposition, a method that uses gases at incredibly high temperatures to cause carbon to crystallize on a substrate material, is what truly creates these diamonds. However, unlike typical diamonds, those created using this procedure are blue and have a higher conductivity. Of course, there are naturally occurring blue diamonds, but they're rarely more expensive than synthetic ones. So NDB uses radioactive isotopes of uranium and plutonium from radioactive power plants to create single crystal diamonds of a few square millimeters in size that carry heat away from isotopes that radioactively decay so quickly that the transaction generates electricity. The NDB converter transforms the kinetic energy of the incident radiation into electrical energy by receiving energy from decay sources. Although each battery cell only produces a little quantity of energy, it is possible to combine many battery cells to consistently power huge machines. The CEO of NDB, Go Sharifi, cites the advantage of scalability provided by the small size of nano diamond battery cells. For instance, a little NDB cell is a perfect match for a wristwatch, which consumes about 2 microwatts. But if you need to power a different application, you may increase the number of stacked cells to satisfy the requirement. Go Sharifi envisions satellites or other spacecrafts being powered by nuclear diamond batteries. A good example is the famous twin Voyager NASA probes, which had 3 multi-100-watt radioisotope thermoelectric generators when they were launched in 1977. Each generator's power output started at just 158 watts, which is less the Voyagers, which have spent decades in space, are gradually losing power, and NASA has been turning off features to keep them powered for as long as possible. They might not last another 10 years, and will permanently lose contact with them, but with nuclear diamond batteries, they can last for eternity here on Earth. Likewise, implanted electronic devices can be set up once during the wearer's lifetime rather than requiring repeated surgeries or energy required to run a light fixture in a home for a year. Elon Musk's Neuralink device, which will interface with the brain, can also be equipped with nuclear diamond batteries, so its initial commercial version won't require constant recharging. If the NDB smartwatch that is planned to be released in 2022 actually materializes, you might own only one watch with a single battery and pass it down for generations without ever needing a replacement. Talk about an electronic heirloom. Of course, NDB hasn't disclosed everything about its nuclear diamond batteries yet, and we recognize that, for instance, we haven't heard about the power density, but right now the most crucial thing is the nuclear diamond batteries and not vaporware. Using nuclear waste in this way benefits the environment as well. For instance, the UK possesses over 95,000 tons of graphite blocks, and by removing carbon-14, their radioactivity is reduced, which lowers the expense and difficulty of safely storing them. Please share your thoughts about nuclear diamond batteries in the section below. Thank you for watching.